All right, welcome to the 3.3 notes. Every student, you should have your iPad out and you should be opening the OneNote application. And I know it's not going to be super exciting to hear me speak, just not me having me actually be there, but do your best to stay on task and follow along. I will try to go at a pace that is similar to that of our actual class, but if you do need more time, please tell the sub to pause and we can wait or rewind a little bit just to make sure you have enough time to get down on the notes what you need to get down. And of course, like I said before, you're in the 3.3 notes under your class notes section in your OneNote app. So our goal today is to continue to prove that triangles are congruent using the definition of what congruence is. Now, we learned yesterday that congruent triangles have congruent parts. Congruent parts of congruent triangles are congruent. So if I can say that triangle ABC is congruent to angle DEF, then all the parts of those two triangles are going to be congruent. And so when I talk about that, it becomes a lot of work because you have to prove that all these sides and all the angles are all equal. Today we're going to learn something called the side-side-side postulate, which at least takes half of the work away by eliminating the need to prove that the angles are congruent. So we're going to begin today with a proof, and we're going to prove that triangle ACD is congruent to angle CAB. And we're going to start this proof with a table. Okay, so we're going to start with a table, and the first statement is given to us, and you can see it's exactly the same as the first part of our proof, which is always the given information. We have all this information just given to us. We know that AD is congruent to CB. So you'll see here, I'm going to highlight that. AD is congruent to CB. They have the same hash marks. We also know that AB is congruent to DC by this information right here and right here. Good, that's great. We also know that some angles are congruent. We know that angle ACD, which is the two-lined angle, is congruent to CAB, the other two-lined angle. We also know that angle DAC or CAD, depending on how you name it, the one-line angle is congruent to the other one-line angle, ACB, on the bottom right. Okay, so that's all of our good information. Now we have to continue moving forward. Now you see that in this diagram, we have two sets of congruent sides. We have ADCB and ABDC. The last side you'll see in both triangles is this middle one, and they share it. So what we need to show is that that middle side, AC, is congruent to its corresponding part, which is also AC. So something is congruent to itself. That's always true. And the reason why? It's the reflexive property of congruence, just like a reflection in a mirror. We know that if I look at myself in a mirror, you should see yourself. So AC, the segment, is congruent to itself, AC, the segment. Now, the third angles theorem is something that we learned yesterday in class, and that means if I have two triangles that have two angles already congruent, and so I'm going to draw my little triangles here, and I know that in those triangles we have the first angle is congruent, and we also know the second angle is congruent. By the third angle theorem, we will know then that this missing third angle, if the other two are congruent, will be congruent. So right now I have DAC congruent to ACB, and I have CAB congruent to ACD. So I need to show that these last ones are congruent, and we know that that's true because the other two angles are congruent. So I will say that angle D is congruent to angle B. Now you could have used a different name. You could have done ADC congruent to angle ABC, or some other combination of those letters as long as D and B are both in the center. And we know that's true by the third angles theorem, that if the two first angles are congruent, then that third one also has to be congruent. So then the last statement I'm going to make in this proof is to go ahead and conclude, since all of the sides are congruent and all of the angles are congruent, that the triangles are congruent. ACD, the triangle, is congruent to the other triangle, CAB. And the reason would be the definition of angle congruence. And I said angle congruence, I meant triangle congruence. All right, I'm going to give you a moment just in case you didn't have enough time to write that down. Now again, the idea is that we showed that all three sets of sides that corresponded were congruent. We showed that all three sets of angles were congruent, and therefore the whole triangles are congruent to each other. And number two, we have a similar circumstance, except we don't have the table or any of the statements or any of the reasons given to us. So given a different set of triangles, LMN and LON, I need to prove that they're congruent with the given information. Okay, so first thing, go ahead and make your table. And again, I'm using this ink to text tool to hopefully make this line straight, but that one wasn't working for me, so I'm going to try it again. Oops, too much. Let's go back down here. So again, I'm going to make a horizontal bar, put an arrow at the end to make it straight. So a bar, put the arrow on the end, make that straight. Good. Now we're in business. So on the left side of your table, you want to write the word statement, because this is where all your statements are going to go in your proof. Anything that you want to say about the triangles will go there. And then the reasons why you make those statements will go on the right side of the table. Now, as you go through, notice that we don't have a table like I normally do with the rows neatly put there. So it becomes extremely important when I write the statements that I number the statement, and I have a corresponding number on the other side for its reason. And just like in any other proof, we're going to go through the given information first. LM, the segment, is congruent to LO, the segment. All right, and just for my sake, I'm going to highlight that LM is congruent to LO. All right, and I'll color code that to remind myself. I also know that MN, the segment, is also congruent to ON, the segment. I'll color code that one green. MN and ON are the same. We know that in this particular circumstance that angle M is congruent to angle O. That's labeled with the one line here. And the other segment, or sorry, the other angle, excuse me, MLN is congruent. MLN is congruent to angle OLN, which is the two-lined angle right here. All right, and that is all just given. Lots of given information here. All right, step two. Whenever we look at the next step, you want to see if there's any vocabulary words in the given, and all we have are congruent statements. And we can say that because they're congruent, they have equal measure for all of these, that the segments would have equal measure and the angles would have equal measure, but that doesn't really help me if I'm doing a triangle congruence proof. Okay, so if I'm doing a triangles congruent proof, all I really care about is showing that things are congruent. Now you see that I already have the two sides sets congruent, and so really I need to show something about this third side that corresponds. And just like the last time, we know that a segment is congruent to itself, and that's both shared on triangle LMN and LON. They both share this LN inside, and the reason why it's congruent to itself is the reflexive property of congruence. Things are congruent to themselves. Now we have another situation where we have two angle sets congruent. So then if two angle sets are congruent, then this last angle, which is MNL, it's hard to do this and make sure all the letters are straight. MNL should be congruent to L and O. And the reason why is because two sets of the angles are already congruent, so then by the third angle theorem, we know that the third angles have to be congruent. And again, we have a situation where we've shown that all the angles and all the sides are congruent, and therefore I can conclude by the definition of congruence, triangle LMN is congruent to triangle LON. And the reason is definition of congruent triangles. Now I think yesterday I said just CP, CTC, and I think I was mistaken on that. So I'd like you just to write the definition of congruent triangles, because that is the proper reason. We're using the definition of what it means to be congruent to prove that these triangles are congruent to each other. All right, again, give you a moment just to write that down. Normally I'd be asking you if you had any questions, but that would be awkward because I'm not actually there and you'd be asking questions and I couldn't answer them and that'd be awkward. So we're going to move on past that and talk about properties of congruent triangles. Now these are very similar to other properties of congruence. The reflexive property of congruent triangles says that for any triangle, triangles are congruent to themselves. We also know that triangles are also congruent to each other, and so if ABC, the triangle, is congruent to DEF, then you can switch the order around and it's still congruent. Finally, the most useful one, if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. And again, if I color code this, it's a lot easier to see the transitivity there. If yellow is congruent to blue and blue is congruent to green, then yellow is congruent to green. And I think I went over this briefly yesterday, but I just wanted to make sure I go over it again today as well. Now, here's the big one for today, and if you have a reference page, this might be a good time to switch over to that and write this postulate into your reference page. This is the side postulate, and I hinted at it earlier. It's going to make our lives a little easier that instead of using the definition of a congruence, we can just say if, again, if all three sides are congruent, all three sets of corresponding sides are congruent, then the triangles are congruent. So all I have to do is show all three sides that correspond are congruent, and then I conclude without showing anything about the angles that the two triangles are congruent. I'll give you another moment here, again, making sure that we have enough opportunity to write down these in our notes. All right. Now again, I always say side or SSS. I don't just hiss like a snake. That's kind of awkward again. Don't just this. It's side. All right, let's keep going. So let's write a proof. Now this is a lot nicer because now I won't have to do anything about angles. I can just show that if all three sides are congruent, then the triangle is congruent. So if I don't have a table, the first thing you want to do if you have a proof to write is to make your own little table. I'm going to do that here with my ink to shape button. Again, left side is always the statements you're about to make, and those statements are usually mathematical statements. And on the right side, we have reasons based on either definitions or postulates or theorems. And of course, the first reason, as always, is given. So let's write down what we're given. Segment KL is congruent to segment NL. Okay, I'm going to go ahead and highlight that for my own use. KL congruent to NL. And we know that KM is congruent to MN or NM. So I'll write that down too. KM, the segment, is congruent to NM, the segment. That's all given to me. I need to prove that these triangles are congruent. And just like I said, it's really convenient that I have this new thing called side because I already have two sides congruent to each other, and you can see there's a pattern today. We need to show that this last segment that they both share is congruent to itself. Can I make that statement? Without me telling you, think about what the statement for number 2 would be and its reason would be. And go ahead and write that down. All right. If you're not really sure what to write down, then maybe you were asleep and need to be nudged. Make sure everybody look at your partner right now. Are they sleeping? Please wake them up. All right. LM is congruent to LM, the segment, and that is because of the reflexive property of congruence. Did you wake them up yet? You're not sleeping, are you? I know it's not super exciting. I'm doing my best to make sure you still get taught while I am gone, so please stick around for this proof, because guess what? It's over. You almost missed it. If you're snoozing, you better be awake now because we're done. We've shown that all sets of corresponding sides are congruent, so I can conclude that triangle KLM is congruent to triangle NLM because of the side, side, side postulate. Okay, side, side, side postulate. Pretty nice. That's a really short, really concise proof. And from here, let's take a little break from proofs. Hopefully you had enough time to write that down. Last chance. And we're back with a sweet little keyboard. Did not mean to do that. So in this number 4, we need to decide whether the congruent statement is true. Explain your reasoning. Is triangle DFG congruent to triangle HJK? Well, let's see if the corresponding sides are congruent. DF, is that congruent to HJ? Let's look. Looks like it is. All right, we check the second set, FG and JK. FG, JK, yep, that lines up. And finally, I do the first and last, DG and HK. Yep, it certainly looks like it. By side, 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 the corresponding sides were congruent, so therefore we can conclude that this is true. DFG is congruent to triangle HJK. True. All right, let's look at the next one. Is AC congruent to CA? AC is 9. CA is also 9. So far, so good. We check CB and AD. CB is 7. AD is 7. All right. Last one, AB is 3. CD is 4. So close. We can see that AB, the segment measure, does not equal DC, the segment measure, so therefore AB, the segment, is not congruent to DC, the segment, and so those triangles are not congruent. It's a false statement because not all 3 sets of sides were congruent. All right, last one, let's check QP. Is everybody still awake? Stay with me. I know it's boring. I'm working through it. QP, that line segment, RS, right here, that line segment, they're congruent. Wonderful. Next one, PT, ST. Here's PT, ST. Good. And then check the last ones, QT, QT, RT. Are those ones congruent? They are. So we would say that this is true. All side, side, side postulate. All 3 sets of corresponding sides were congruent, so the triangles are congruent. Last chance to write that down. And it's gone. All right, back to another proof. This will be the last one for our video, and so you'll have some time to work on your homework after we're done with this, which is good news for everybody. Oops, I forgot to turn on ink to draw. No wonder it didn't make a straight line. Let's try one more time. Make a table for this proof. Again, on the left side, we're going to do a statement. And reason. All right, just like always, reason number 1, give on. That rhymes with 1, right? Give on. Now I can just tell you're rolling your eyes. So now I don't have to be there and you're like, wow, Loveless, so terrible. WX is congruent to VZ. Here's WX. Here's VZ. Excellent. WX is congruent to segment VZ. We also know that WY is congruent to VY. Okay, those are corresponding as well. I'll write that down. WY is congruent to VY. And finally, we know that YZ is congruent to YX. YZ, the segment, is congruent to segment YX. All right, YX, YZ are both congruent. Now I want to show that triangle VWX, WX. Now be careful. You might think, hey, we're already done. We already showed that these two are congruent, but they want to show that VWX, which is this one, VWX, is congruent to WVZ. And WVZ is the other triangle going like this. All right. Well, that proves to be a little bit more difficult than what we originally thought, because I don't know about you, but I was kind of excited that we might be done right away. But we're not. So let's get a plan together. We've already shown that the long leg is congruent with the 3 marks, so that's good. Now what we need to show is that this other side on the left is congruent to itself, and we also need to show that these diagonal hypotenuse sides are going to be congruent to each other. Let's start with the easy one. We know that WV should be congruent to itself, okay? And so let's go ahead and write WV, the segment, has to be congruent to WV segment because that is the reflexive property of congruence. And so far we have 2 of the sides that I want. I've shown that this side and this side are both the same. And I've also shown that this side is congruent to itself. And like I mentioned, the last thing I need to do is show that the diagonal sides are congruent to each other. Now, the way that we do that goes a little something like this. So I can get that to erase. There we go. I'm just going to erase some of the highlighting just to make sure that you can see this clearly. So the next step to show that those 2 diagonals are equal, we have to show that they're made up of equal parts. So we know, for example, that this segment here is made up of the 2 smaller segments. We know that VY, the segment, plus, and actually I should make the measure here, VY, the measure, plus YX, the measure, equals VX, the measure. And for the same reason, WY, the measure, plus YZ equals WZ. What would be the reason why those bigger segments are made up of the smaller ones? All right, not everybody at once. Don't all just yell at the screen. It's the segment addition postulate. Segment addition postulate says that the larger pieces are made up of 2 or more smaller ones. Okay? Step 4. So we know that some of these are already equal to each other. For instance, we know that VY should be equal to WY. For what reason? Well, we know that these are congruent segments, so by the definition of congruence, we can say that their measures are equal. Okay? We can make that same conclusion with all the other congruent segments. WX is equal to VZ. We know that YZ is equal to YX. That's the definition of congruence. Now, I have a black bar here that's kind of in our way, but don't worry about that. We're going to just write right below it. And we'll go on to step 5. Now, remember my goal. My goal is to show that these 2 segments are equal to each other. Now, the way that we do that is to say, hey, VY and YX, I can replace those with different ones, right? Like this particular equation here, VX is also equal, and I can replace VY with WY and YX with YZ. And what is that called when I replace numbers in an equation? That is the substitution property of equality. Now pay attention, because look, WY, YZ, WY, YZ. Do you see how those parts match? Then what can I say about VX and WZ? I can replace this whole thing that's blue with WZ for the next statement, statement 6, that VX is equal to WZ. And you can use either the transitive property or the substitution property again. I think I prefer the substitution property of equality. So I'm replacing the blue with what it's equal to, WZ. So now I've shown that the measures are equal. What does that mean about the segments themselves? If they have equal measure, then Vx is congruent to WZ by the definition of congruence. You guys are so smart. I bet you all said that at the same time. The definition of congruence. If I look at my picture, that means that Vx and WZ are congruent now, and I've shown that all three sides are congruent, so I can wrap this up by saying that triangle VWX is congruent to triangle WVZ. That is by the side, side, side postulate. All right. I'm going to give you a moment again to copy this down. As you're writing, I'm sure that you probably have questions, and unfortunately, I'm not there to answer them. So your best bet is to message me on Schoology. I should have access to my email as I'm out at EDC, and I'd be happy to answer your questions that you have. Your homework tonight is to work on the 3.2 worksheet, which will be distributed to your folders soon. By the time you're watching this video, it should be done. Thanks for watching. Make sure that you use the rest of the time. It's only been about 27 minutes. Make sure you reuse the rest of the period wisely. Use it to get homework done. Ask me questions if you get stuck. And I hope you have a wonderful day. Thanks.